Okay, let us apply the ERO method. Okay, so the step involved in ERO, the first step is write A in the augmented form. Okay, when I say augmented form, it must be in this form. Write your A beside your identity matrix. Alright, so the second step, use characteristic that or the rule that I mentioned before, okay, to reduce A to identity. Okay, so we write the augmented form E I. Now our aim or end product, we aim to reduce A here become identity matrix so that the right hand matrix will also change accordingly to the operation and become our inverse. Okay, so this is our inverse. Alright, so the rule is we will reduce matrix A, okay, following element to element. Okay, so the rules is you go down first, change A11 to become 1. Okay, change this, reduce this to become 1, then followed by the bottom element. Okay, reduce this to 0 and reduce this to 0. Okay, and then go to here, A to 2, reduce this to 1, go down, reduce this to 0. Okay, follow and then go to here, A33, reduce this to 1, goes up, reduce this to 0, reduce this to 0, lastly reduce this to 0. Okay, and you will get this part become identity, and in throughout the process of reducing this to I, you will also automatically change all these row as well. Okay, because it will involve the whole rule each time you perform the ERO. Okay, so when you change the third row, everything here will change. Okay, the operation will involve the whole row here. Okay, so that is why when we get this matrix A to become the identity matrix, this will change to inverse. Okay, because the whole row will change. Alright, but the flow is going down, up, down, there, and then go up. Okay, down, go there, go down, go there, go up, and go there. Okay, see, the process is you reduce this, go down, and then go up to A to 2, reduce to 1, reduce next to 0, and then go here, reduce this to 1, and goes up, and then go to the left. This is the last element that should change. This is the first. Okay, go down, goes up, goes down, to the right, goes up, goes to the left. Okay, so that is the flow to change the element. Okay, so let us go straight to the example. Okay, finding the inverse by using the ERO. Okay, so remember that there is no fixed way or rules, okay, which characteristic to use. Okay, it is based on your creativity, okay, which one you want to reduce first, but remember it must follow this way. This should be your first, change to 1, and then reduce this to 0, reduce this to 0, Okay, and then goes up. Reduce this first to 1. Okay, and then go to the bottom here. Reduce this to 0. And then go to the next, which is this. Make sure it is 1. And then goes up. This make sure become 0, become 0, and become 0. Okay, whether you want to do characteristic 1 or characteristic 2 or characteristic 3, it depends on the situation, depend on the rule that you want to change. Okay, sometimes you don't even need to apply all the 3 rules or the 3 characteristics. Maybe just applying 1 or 2 characteristics will be enough to change the A to identity matrix. Alright? So let us solve for A first. Alright, so first step, we write this matrix in the augmented form. A, I. Okay, so what is our matrix A? Our matrix A is 1, 0, 3, minus 1, 2, minus 2, 2, 3, minus 1. Okay, separated by the straight line. Write the identity matrix I. Okay, since this is 3 by 3, so your identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. So remember our aim or our end product, we aim to reduce A to identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, so that we have our inverse matrix on the right side. Okay, so in order to reduce this, our first aim is to reduce this to 1. Okay, this is our aim to reduce this to 1. And we are lucky because for the first row, first column, it is already 1. Okay, since this is already 1, we proceed to the second element of the first column, first row, which is this one. So our aim is to reduce this to 0. Okay, so this element must become 0 here. Because this is already 1, now our aim is to reduce this to 1. So that we have 1, 0, 0 here. Okay, so now we need to think of a way to reduce this to 0. Okay, now we can write to here because our aim is to reduce row 2. So only row 2 will change. Okay, so we can write the other row that does not change, that will remain unchanged. 2, 3, minus 1, 0, 0, 1. So whatever operation that you perform here won't change the first and the third row. It will just change the second row. Okay, so our aim here is to reduce this to 0. Alright, so in order to reduce this to 0, we need a help from the other row. So which row between the first and the third here that can reduce R2 to 0? Okay, you have two ways. If you choose row 1 to reduce to 0, you should take row 2 plus row 1. Because row 2 is negative 1, if you plus with 1, okay, which is row 1 here, you will get 0 for the aim element, right? It doesn't matter what happened to the rest of this. Okay, because our aim is to change this element only. So our concern now, whatever operation, whether it is addition or subtraction or multiplication with a scalar, it must change this element only. Okay, this is one way. Okay, the second way, you can also use third row to help you. So R2, if you plus with half multiply with R2, you will get minus 1 plus half multiply with 2. This will also give you 0. Okay? But remember, if you multiply, it will change the whole row for this operation. Okay? Right. So I will choose the first one. This one. Because it is easier, we don't have to involve with a scalar. Okay? Just to minimize the minimize the error. So now, R2 will change with the operation of R2 plus R1. Okay, so now you just concentrate on R2. So what is R2? R2 is minus 1. The whole row for R2. Minus 1, 2, minus 2, 0, 1, 0. And you plus with R1. What is R1? R1 is 1, 0, 3, 1, 0, 0. Okay, so perform the operation. Minus 1 plus 1, you get 0. 2 plus 0, you get 2. Minus 1 plus 3, you get 1. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0 is 0. So this is your new R2. Okay, so you transform this to second row. So it become 0, 2, 1, and this will change to 1, 1, 0. So this is what I mean for ERO. Only the row will change. Okay, so now we are done with our second aim. Alright, so next aim is to reduce 2 here to 0. Okay, because it must go down, up, down, up, down. Okay, so we've done with this. Now it is time to reduce this to 0. Okay, so that we will achieve this. Okay, so in order to change 2 to 0, the only row that can help us to do so is row 1. Okay, so from here, sorry because I don't have enough space. So now our aim to change row 3. So we write row 3 because only row 3 will change. Okay, based on this operation. Alright, then we need to decide which row we want to use to reduce this to 0. Okay, so we cannot use the second row here because second row is already 0. If you take 2 minus 0, you still get 2. If you if you take 2 plus with a 0, you still get 2. So it won't change anything if you choose row 2. You see? Okay, So the only row that can help you is row 1 here. Okay, how? By multiplying row 1 with 2 and we do subtraction. Okay, so we will subtract with 2 multiply with row 1. Okay, only this can reduce 2 to 0. Alright, so to avoid doing a mistake, we can write first the row that won't change. Okay, so row 1 won't change, row 2 won't change. Alright, the only row that will change is row 3. So based on the calculation, we need row 3 which is 2, row 3 which is 2, 3 minus 1. Take the whole row, okay? So 0, 0, 1. And then we will subtract with 2R1. What will happen to R1 when we multiply with 2? It will become 2. It will become 0. It will become 6. It will become 2. It will become 0 and 0. Okay, now let us perform the operation. 2 minus 2, you get 0. 3 minus 0, you get 3. Minus 1 minus 6 minus 7. 0 minus 2 minus 2. 0, 0 is 0. 1 minus 0 is 1. Okay, so transform this to the matrix here. So now our row 3 becomes 0, 3 minus 7 minus 2, 0, 1. Okay, so next, we haven't finished yet. We must reduce the next element. Okay, remember after we're done with the first column, we go to the second column, reducing this to 1. Okay, now our aim is this, reduce to 1. How do we reduce this to 1? Okay, the easiest way to reduce an element to 1 is by multiplying the row with a scalar. Okay, so here, what we can do is we can transform row 2, okay, this element to 1 by multiply the row 2 to 1 over 2. Okay, when we do that, okay, so let us write first the row that won't change, will remain the same, is row 1 and row 3. Okay, the only row that will change is only row 2. So row 2 here we multiply with the scalar 1 over 2. So 0 will remain 0. 1 multiply with half will become 1. 1 multiply with half will become half. Then this also will become half and 0. You see? Okay. So now our aim is achieved. Okay, reducing this to 1. Alright, so next aim is to reduce 3 from the third row to 0. Okay, now this is our next aim. Reduce this to 0. Alright, so in order to reduce R3 to 0, okay, in order to reduce R3 to 0, the operation involved is, so now R3 will change, do not multiply or do anything to R3. We must find a way to reduce this to 0. You cannot, the only row that you can choose is row 3. row 2. Okay, you cannot choose row 1 because row 1 won't help you because this is already 0. Okay, you multiply anything to this and perform subtraction or addition, won't change anything to 3. Okay, and in fact it will affect the the first row element here that you have already changed, and it will become a number again. We don't want that. Okay, so please choose the row wisely. All right, so second row can help you to reduce R3 to 1. What you can do is you multiply 3 to R2 and you subtract. That will reduce 3 to 0. Okay, so the operation that will involve is R3, 0, 3 minus 7, minus 2, 0, 1. Okay, you multiply, you will subtract. Okay, minus 3 multiply with R2. So R2 times 3, sorry, okay, R2 will multiply with 3, so R2 will become 0, 3, 3 over 2, 3 over 2, 3 over 2, and 0. Okay, that the operation will give reduce R2 to R3 to 0, 0. So minus 7 minus with this, so you will get like 14, 17 minus 17 over 2. Okay, okay, so the rest of the operation will give you minus 7 over 2, minus 3 over 2, 1, and so on. Okay, so you replace this to the matrix here. So 1 and 2 won't change. 1, 0, 0, 0, 1, half, 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 0. This become 0, 0, minus 17 over 2, minus 7 over 2, minus 3 over 2. This is 1. Right? So we have completed this. We have reduced this to 0. Okay, that. Now our aim is to make this to become 1, which is this one. Okay, this must be reduced to 1. How to do that? We can multiply with a scalar 2 over minus 17 to row 3. Okay. Okay, so we multiply with minus 2 minus 2 over 17 to R3. Okay, so write first the row that won't change, that does not involve with the operation. Okay, now row 3 will change. When we multiply with minus 3, it becomes 0, 0, 1, and that will become minus 7, will become positive, minus positive 7 over 17. Okay, 3 over 17 minus 2 over 17. Am I doing the correct calculation? Okay, so yes, they are correct. Right, so next, we have achieved this. Now our aim is to reduce this to 0, which is this one. Okay, we must reduce this to 0. We proceed to the next slide. Okay, so we want to change R to, okay, which row we want to use to help us to reduce half to 0. Okay, we will use the third row. Okay, so we multiply 2, we minus with 2, multiply with R3. Okay, why we choose R3? Because when we multiply 2 to R3, this will get 0, this will get 0, and when we subtract 1 to 0, it will remain 1 here. Okay, if we choose to use rule 1, okay, it will affect the row that we have changed here. Okay, so it will affect the row that we have changed here. It may be affect this, or maybe to affect this. So please choose the row wisely. Okay, we don't want it to keep changing, the row to keep on changing the value. Okay, once we change it, we must remain it. Alright. Okay, so we write first the row that won't change, which is row 1, 100, and row 3, 0, 0, 1, 7 over 17, minus 2, 17. Okay, now only row 2 will change, and row 3 is only a helper to reduce our row 2. Okay, what happened here is row 2, 0, 1, half, 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 0. We subtract with 2 multiply with R3. So all the R3 we multiply with 2. You get 0, 0. Oh, I'm sorry. Yes, correct. This will become 2. I'm sorry. So this is multiply with half. Okay, so this is half. Okay, when we multiply with half, you get this 7 over 34. This is 3 over 34. It will become minus 2 over 34. Alright, so the result that we have is 0 minus 0 is 0, 1 minus 0 is 1, half minus half is 0, and this will change to half minus this, you will get 17 minus with 7, that will give you 10 over 34, and then 17 minus 3, you get 14 over 34. This is 0 minus with minus, you get positive 234. Okay, so we write this back to the matrix: 0, 1, 0, 10 over 34, 14 over 34, 2 over 34. This is 14. Okay, so now our aim almost done. We have one more left, which is 3. We need to reduce 3 here to 0. Okay, so now, in order to reduce our, okay, so go to that way. So now we want to change R1. Okay, so to help us to reduce R1, we use R3. So minus 3R3. Alright, when do we do that? We have 0, 1, 0, 10 over 34, 14 over 34, 2 over 34, 7 over 17, 3 over 17, minus 2 over 17. This is 0, 0, 1. Okay, so when we apply this R1, which is 1, 0, 3, 1, 0, 0, minus with 3R3. So R3 is 0, 0, 3, 21 over 17. 3 times 3 is 9 over 17. Minus 6 over 17. So you will get 1, 0, 0. 17 minus this, you get 4 over 17. 0 minus this, you get 9 over 17. Minus 9 over 17, you get this 6 over 17. Right, so transform this back to the matrix. So you get minus 4 over 17, minus 9 over 17, 6 over 17. Okay, so now we have successfully transformed or reduced our matrix A on the left side to matrix identity. And whatever you have on the right here, this is your A inverse. Alright, so here your A inverse is, we write it nicely, minus 4 over 17 minus 9 over 17, 6 over 17. This one we can reduce to 5 over 17, 7 over 17, 1 over 17, 7 over 17, 3 over 17, minus 2 over 17. Or we can factor 17 out. A inverse equal to 1 over 17 minus 4, minus 9, 6, 5, 7, 1, 7, 3, minus 2. Okay, so done. That is our inverse. Alright, so do you see the concept now? From augmented form A identity, using ERO, we reduce the matrix A to identity, and the whole or row operation will transform the matrix identity on the right side become our inverse. Okay, so before I end this lecture, what we can conclude from this operation, okay, what I mean is ERO, capital ERO, elementary row operation, right? In order to reduce the row to 1, okay, you can apply a rule of multiplying scalar, multiplying a scalar. Okay, so if each time you see reducing, you want to reduce the row to 1, okay, I mean for the diagonal part here, okay, you just multiply with a scalar. For example, if you have 2/7, to reduce this to 1, what you do is multiply this row, the only row that is involved, with 7/2. And you multiply with 2/7, you'll get 1. Okay, so that is for the diagonal element. Okay, the main diagonal. So to change the main diagonal, you just apply the rules or characteristic of multiplying a scalar. Okay, in order to reduce the row, the element of the row to 0, you can apply addition or subtraction with other row. Okay, that's it. Very simple. I will leave example B for you to try at the hostel, okay, to practice ERO. Okay, so I have prepared the answer for you. Okay, you can use this as a guide in order to make sure that you has applied the correct method in order to find the inverse. Okay, so remember one thing, regardless of the method you use, you should get the similar answer. So I guess that's it for this on this lecture. So I'll see you again in the next lecture. Thank you.